Hello and welcome to this lesson on constructs and techniques. This is part of your Unit 4 programming, assignment A. So the notes from this presentation, I'm going to ask you some questions at the end of the presentation for you to complete, and also using pages 233 to 237 of the textbook as well. So, programming constructs and techniques and their implementation in different languages we're going to look at. Programming language constructs are the building blocks used to create a program. You'll use them in many different ways and apply them various techniques to solve the problems you are given. One thing you will discover very early on is that many constructs and techniques are common across a number of languages, which means that your knowledge can easily be transferred between languages. Code samples from a number of different popular programming languages have been used to allow you to compare and contrast these constructs and techniques. However, in the textbook chapter, it uses Microsoft C#. That C# is a very popular language used within the software development industry. As your skills progress, you should find it relatively easier to convert these code samples into different target languages. Command words. The concept of command or reserved words is at the core of most programming languages. These reserved words cannot be used by a programmer to name things. We'll look at identifiers in a moment. Instead, they are used to command a specific action, such as open a file, clear the screen, or put text on the screen. The quantity and purpose of reserved words can vary greatly between different programming languages, but as you become more experienced as a developer, you'll start identifying recurring concepts. Identifiers. The identifier is a programmer-friendly name which represents the quantity stored in the computer's RAM, in the computer's memory. Many types of identifier are used in programs, but the most common types are variables. This is an identifier representing a value that might change while a program is running. And there are constants. This is an identifier representing a value that will not change, that will stay the same while the program is running. I'll give you an example. When a person logs on to a program, their name and password is typically used. Those names and passwords are stored as variables because these details would be different for each different user of the program. However, calculating something like VAT, value added tax, which is a set amount, in the UK it's 20%, added to the cost of an item, that can be a constant variable. VAT can be a constant variable because this doesn't change. Okay, the value doesn't change on every sale where VAT is added, so it could be set as a constant. In order to create or declare a constant or a variable, you must provide the programming language with two things, a name and a data type. You should also choose a sensible and meaningful name. For example, a good variable name for the storing of a user's name would be username. Some names cannot be used because they are reserved by the language for a particular use, typically because they are command words. These reserved words vary between different programs, so just watch out for that when you're programming and coding. There are many different naming conventions used in programming. Two we're going to look at now are called camel case and snake case. These are probably the most popular types. So looking at camel case, you can see here in this variable is called user age. You can see that the second word, age, is an uppercase A to just show you that there are different words used in a variable name to make it a little easier to read. When using snake case, it's an underscore, so it uses lowercase letters, but an underscore is used to separate each word in the variable name. So it allows you to use sensible variable names that can be read, that can have a number of different words made up, but it has to be one consistent line of characters. So you use a capital letter if you use camel case to separate that, to show different words, or you can use snake case, an underscore character, to separate out different words. Most programming languages also contain the concept of local and global variables. The easiest way to think about this is to remember that global variables can be used anywhere in the program, in your program code. Local variables are limited to being used in a block of code within a function in which they are declared. Data types. Almost all programming languages support the concept of data types. A data type is used to define what kind of value a variable or constant can store, what operations can be performed upon it, and its behavior within the program. Most programming languages offer many different data types for the programmer to use. As you can see on the screen now, some different data types that are used. Character stores single characters. Now, a character can be a letter of the alphabet, a digit, a number, a blank space, or a punctuation mark. String is a collection of characters. An integer is a whole number, no decimal places. A real number, sometimes called a floating point number, stores decimal places. And Boolean data types. These are logical values that store true or false, ones or zeros, yes or no. So, because these data types are quite common, it's possible to compare their implementation in different types. So I'm going to look at a table on the next slide that shows you different types of how variables are used in a couple of different programming languages. Some languages are said to be strongly typed, while others are weakly or loosely typed. This makes a fundamental difference to the formality of the programming language. Strongly typed programming languages require data and data types to be consistent when used. For example, in Java, if a variable has been declared an integer, it should only be used to store integer variables, otherwise errors occur. This is because Java is a strongly typed language. However, the C language is loosely typed. It will implicitly convert the data to the correct data type that the variable expects, without the programmer needing to add any specific code to do so. This is a convenient feature, but can also lead to unexpected results. Tip for you, be careful when dealing with data types. Always think about the data you want to store and what data type is the most appropriate to use. Getting the data type wrong can lead to problems such as truncation of decimal places or incorrect rounding, which can be a bit of a problem if your application deals with monetary values and money. Statements are the core aspect of many programming languages. They define the basic actions that can be performed and often combine a number of language constructs. I'll show you some common examples in the next slide, in the next couple of tables. There are many similarities between them. For example, they are very case sensitive, but only some of them require semicolons to mark the end of a statement. Case sensitive, so when a programming language recognises the difference between uppercase and lowercase, or capital and lowercase characters. The command word, if it's expected to be in lowercase, an error will occur if you unexpectedly write it in uppercase. Most programming languages tend to prefer lowercase. So let's have a look at some construct comparisons. So we're looking at the C language and we're looking at Microsoft Visual Basic. So when you're defining, for example, an initial letter in someone's name, perhaps, that would be a character because it's a single character. In C, you use char initial, semicolon. Visual Basic, dim initial as char. Username would have a string of characters. In C, character char username 20, which means this particular string has a maximum length of 20, can have up to 20 characters in it. Dim username as string is used in Microsoft Visual Basic. Age would be an integer because an age is a number without decimal places. So it's int age, semicolon, dim age as integer, Visual Basic. Price would be a real number or a floating number because you want it to have decimal places potentially. So float price, semicolon in C. In Visual Basic, dim price is double. Valid or Boolean, yes or no, true or false, not available in C, but in Visual Basic, dim valid as Boolean. Now, looking at some more examples of statement types, the purposes and expressions. An assignment, as you can see in Microsoft C#, so we're assigning user age to a value of 17, similar in C++. In Ruby, it doesn't require the semicolon at the end. Input, so username in this case equals console.readline bracket semicolon. In C++, cin to greater than symbols username. In Ruby, username equals gets. That's when you're wanting input from the user to type in a username. Output, so putting output on screen. In Microsoft C#, console.writeline hello, so that hello would appear on the screen. C++, cout, less than, hello. And then Ruby puts hello. So you can see when you're putting output, that's quite different between the different types of programming language. Assignment is very similar, output quite different. So it's things that you need to learn and develop, different constructs, expressions used in different programming languages. Okay, just a little bit more on control structures before we go into subroutines. The algorithms that control programs are typically built on a combination of three basic programming building blocks known as control structures. These control structures are sequence, selection, and iteration. Sequence is one action after the other. None are missed, none are repeated. Selection, actions are chosen based on a supplied condition, which is either true or false. So like if statements. And iteration, action repeated a number of times, typically until a condition is no longer true. So that's example of for until, while until, for next type loops type of things. Logical operations. Operators are special symbols used to perform special tasks in a program. Logical operators such as and, or not operate on Boolean principles. They are used to combine conditions in if statements and various loops. Care should be taken when moving between languages. For example, in some languages, the single equal sign is used to test for equality, while in other languages, it will use a double equal sign, as you can see in this example here. So testing for equality in C and C++ is double equal sign, in Visual Basic a single one. Addition is similar across different languages. Test for inequality is different in C and C++, uses an exclamation mark and an equal sign. Visual Basic, it's less than and greater than, so that means not equal to. And logical operators in C and C++ use the ampersand and together, and uses the word and lowercase in Visual Basic. So you can see again with logical operators, it's about getting to know the language and just making sure what constructs are used. In terms of subroutines, functions and procedures, these are terms used in procedural programming where code is split into a number of different modules. Each module may be called a subroutine, a function or procedure, depending on the programming language used. Each module is responsible for performing a single task, and it's typically somewhere between 5 and 50 lines of code in length. The use of these modules means code tends to be easier to write, read and debug. Code written in this way can usually be reused through multiple solutions and allows a single application to be divided and worked on by multiple programmers simultaneously, which means development time can be reduced. Final tip for you, almost all programming languages have library functions which programmers can use when solving complex problems. These allow the programmer to perform common but crucial tasks on data, such as formatting its appearance, finding length of a string, or the square of a number. You can also download and install third-party functions from reputable websites to expand programming languages. Okay, so I will email you a link to this video. You already had the video in the slides there. I'll email you the slides, the pages of the textbook that are relevant, and I'll email these questions for you to do for next Thursday, 11th of June. Send them back to me. Okay, good luck with that, and bye.